Hey everyone, today we are starting on page 8 in your packet. Yesterday we talked about perpendicular bisectors and angle bisectors. Today we're going to see what it looks like in a triangle. And you're going to see some terms and hear some terms over the next couple of days. But at the end I'm going to give you a way to kind of keep them all straight. So today we're going to talk about those bisectors of triangles. When 3 or more lines, it should say 2 or more lines, intersect at one point, they're said to be concurrent. That's not a word that you're going to have to memorize. You'll just see that term pop up, and I just want you to know it's just the point. The point of concurrency is just the point where they intersect. That's all it is. So down here, point P would be the point of concurrency. Now, the first one is called the circumcenter. You may want to highlight this. So circumcenter is made up of perpendicular bisectors. So if you look at this picture right here, this side has been cut in half and this line is perpendicular. We can tell by the square. Same with over here and over here. The point where those all meet is called the circumcenter. So it cuts the sides in half, but what it also does is it's equidistant from the vertices of the triangle. So that means equal distance to each of your vertices or your points. So what that means is A to P, B to P, and C to P are all the same size. All right, so it cuts the sides in half and it's the same distance to each angle. Now, sometimes it's inside the triangle, sometimes it's outside the triangle, and sometimes it's right on the triangle, depending on the type. And it gets its name because it's the center of a circle that's circumscribed or drawn around a triangle. These things you do not need to memorize, but you do need to make sure you're good to go with this. All right, so let's see what this looks like. It's important that you look at your picture label. I like to look at the picture and find everything I can right away. So first of all, it's made up of perpendicular bisectors. So that means that point D is called the circumcenter. All right, and since it's perpendicular bisectors, that means this side's 16 and this side's 16. If this is 15, this is 15. If this side's 17, this is 17. All right, so let's see, DG. Actually, let's talk about what we just said. Now, it's cutting the sides in half, but from D out to E, from D out to F, and from D out to G are all the same. So since this is 19, these are both 19 as well. All right, so it cuts the sides in half and it's the same distance to the angles. So now that I've labeled everything, it's easier to answer the question. So from D out to G, 19. EK, 17. FJ up here, 15. And from D out to E is also 19. All right, so again, it cuts the sides in half, same distance to your angles. Now, if you want to find the circumcenter, again, it's made up of perpendicular bisectors. So you're going to draw a perpendicular line through the midpoint. And it's easiest to look at the two sides that are vertical and horizontal. So let's look at this bottom part. This has a distance of 4. What's half of 4? 2. So there's the midpoint of that line. Since your line's going straight across, if I draw a line straight up and down, that's the perpendicular bisector of this line segment. So let's do this side over here. It goes up to 6. Half of 6 is 3. So there's your midpoint. And then draw your line. Since it's vertical, we're going to draw it horizontal. The point where those lines meet, right there, is your circumcenter. And those are have the coordinates 2, 3. All right, you can pause the video and try this next one. Okay, this goes up to 5. Half of 5 is 2.5. Okay, this side goes from 0 to negative 8. It has a length of 8, so half of that is 4. So there's your midpoint right there. So now just draw the line vertical to it and the point where they meet is your circumcenter. So it's the point negative 4 and 2.5. Okay, the other one is incenter. Now with circumcenter, it was cutting the sides in half in the same distance to the angles. With an incenter, it does the opposite. The incenter is made up of angle bisectors, so it cuts each angle in half. And then it's the equidistant from the sides of the triangle. So that means from A to C, from A to B, and from A to D are all the same. And I want you to notice it makes up all these right triangles. So if you're ever looking for the side of a triangle, you can use your Pythagorean theorem. That'll come up. Okay, and this gets its name because it's the center of a circle that's inscribed, where the circle's inside of the triangle. And it's the incenter, and it's always inside. Again, these two things you don't need to memorize, but you do need to know that it's made up of angle bisectors. So your angles are being cut in half, and it's the same distance to the side. Okay, so the distance from P to CE. Well, if you notice, the distance from P to CD is 9. So if I went to any other side, you'd want to go straight at it, which would form a right angle. And that's also going to be 9. Same thing down here. It's going to be perpendicular to it, and it's also going to be 9. So the distance from P out to CE is 9. Now, the angle measure is a little different. We're looking for PDE. So if we follow the path P to D to E, we're looking for this. Well, these are angle bisectors. So if this is 36, this is 36, and this whole angle is 72. This whole angle is 40. Well, if you look, we have one big triangle here. All the angles in a triangle add up to 180. So if I take 40 and 72, that's 112, and subtract it, we get 68 for angle D. Well, if this is an angle bisector, PD is an angle bisector, if the whole thing's 68, cut it in half. So each of these would be 34 degrees. If it's an angle, make sure you use degrees. Okay, same thing on the next one, the distance from K to YZ. Well, the distance from K to this side is 33, so out to here would be 33 as well. Okay, so 33. And then for the angles, again, this is 39 degrees. If this is 18, this is 18, so this is 36 degrees. So if I want to figure out what the measure of angle KZY, which is right here, figure out what the whole angle Z is and divide it by 2. So we'll take 39 and 36, 75, subtract it from 180. So this whole thing's 105. If you want to find both halves, we'll divide by 2. So it's 52.5. Okay. Now, before we go on, on the homework, 7 and 8 are very similar. I want to go over number 7 with you. This wasn't covered in the notes. So it says PY is 2. All right. I'm actually going to zoom in a little. HP is 3. It wants us to find HY. if you notice, since this is right, and you're dealing with a right triangle, so I'm going to pull that right triangle out. So this is 2, this is 3. We're looking for HY. Anytime you're looking for the missing side of a right triangle, and you'll see these pop in all throughout the year, use Pythagorean theorem. Whatever number's across from your right angle is your C. So we're going to do x squared plus 2 squared equals 3 squared. So we have x squared plus 4 equals 9. And then to get x by itself, we'll subtract 4. And then to get rid of the squared, we'll take the square root. So x equals the square root of 5. If you put it into your calculator, you get 2 point something, but we can leave it. All right, so once in a while, you might have to use some Pythagorean theorem. All right, otherwise your homework is the 5-2 practice, so the rest of page 11, well, all of page 11, so if you didn't get this down, there you go. And then page 12, make sure that you graph those triangles first. All right, if you have questions, stop by the math lab. Have a great day.